Sound good, Jim? All right, yep.
Okay, cool. So my name is Austin Proby, and I'm from Emergent Space Technologies, and today I'm going to be talking about Summit, which is the scalable utility for... Yeah. Which is the scalable utility for multi-mission integration and testing. It's an internal tool that we've been developing for our software development that really helps with sort of advanced flight software work. I forgot to put authors on the front side, but this is done by myself, Brendan O'Connor, Graham Bryan, and Nick Merlin all from Emergent. So brief overview, I'm going to kind of touch on the motivation of why we built this tool, what the concept is, and then kind of go over the back end a little bit. And then I was going to try and do a demo, but that didn't work with the AV setup, so we have a video of a demo that we'll show. Okay. So Summit. The reason we had to build this tool was because sort of the small sat industry is moving in a direction of these companies that are producing commoditized buses. So you can, it's like Blue Canyon et al. You can go to them and say, I need a bus with roughly these properties, and they can give you a quote right away. And with minimal modifications, they can put your payload on it, they can stick your flight computer in it, and they have a defined API for interacting with the bus and getting information from it. So there's a lot less risk sort of in the bus development side of things for small sats. But at the same time, flight software is becoming more and more complicated. So there's new mission areas that people are trying to move flight software into that where the software has to do more things. So a couple of those are autonomy, network systems, and modular reusable software, which are all things that I think people here are very interested in. But when you kind of have more complicated software that has more interactions with more components that are coming from different people, there's more risk that ends up being contained in the flight software. And when you ask that software to do more things, there's obviously more risk there too. So the V&V tools that you use need to kind of evolve to keep up with this extra risk and find a way to validate the software that you're producing when it's more complicated than just running unit tests. So to meet that need, we've developed this internal tool called Summit, and there are a couple new technologies that make this possible. Wait, did I skip a slide? Nope, okay. So one of those is containerization. So that's tools like Docker and Kubernetes that allow you to run many parallel instances of flight software or build environments at the same time without having to have somebody configure each one. Virtualization, we had a good presentation on using QEMU to emulate flight software, not flight software, but actual flight processor boards in a containerized, or in a software environment. But if you combine QEMU and containerization, then you can deploy multiple of these emulated flight software boards and test your flight software in its flight configuration in a virtualized environment. And when you combine that with containerization tools, then you can do that in parallel. There's also a lot of great Python tools that have recently become available to interact with, to manage automation, to interact with containers, and to use, essentially to get information out of those containers and use it and store it with databases and interact with web front ends, which allows you to kind of make use of all the information that you're generating from all this large-scale parallel flight software testing. So anyway, and obviously Git, which we'd all be very sad without. So you can kind of combine all of these things to produce this tool that we call Summit. So the concept is that it kind of extends the concept of continuous integration to use in scenario testing. So a lot of people are familiar with the concept of having continuous integration where you have a server that when you're doing pull requests or something like that, you have a set of unit tests that your system has to pass before it will get integrated into the main software. But we've discovered that with extremely complicated flight software with lots of interactions, either your unit tests and everything that you run for your pull request will take 24 hours, or you can't test anywhere near the full set of things to actually be sure that that pull request is good. So we've kind of, and we don't want to have the developer sitting waiting 24 hours for a pull request to pass, because then it gets really hard for them to work with the rest of the team. So we've kind of kept unit tests and that kind of thing in the standard continuous integration pipeline, but added this massively parallel tool on the end of it to do more testing after initial pull request. So we're leveraging scalability, we're leveraging containerization to provide that scalability and parallelization. So it's a tool that we really wanted to build it so that it can work with whatever flight software development we're doing, and we do all of our flight software development in Linux. So it's really just it can sit on top of any flight software development that you have in Linux, and because it uses containerization, if you have any kind of weird build dependencies or anything that's specific to your project, it can easily incorporate that. If you're familiar with deploying things in Docker, it's really easy to do, and it can scale really well and really fast. And then it has a bunch of tools to automatically manage versions and execute tests and save the results. So kind of talk about a little bit of the Summit architecture. There's a manager, so that's a project manager, which kind of it runs the whole Summit show, orchestrates how the containers run, and gets everything started. And then there are containerized test managers, which are where each of the flight software environments run their tests. And then, so every project has a pair of components. So there's a project environment where the build and test generally take place, although there's a special exception for containerized testing, which I'll talk about in a moment. And then a project database. So it's not really useful to just be able to run a bunch of tests if you can't find out what happened in those tests. So it's really important that we save the results of the test. And we don't just save sort of pass-fail results. We actually get full state data for all of the tests that we're running and save that in a big database backend, so you can do forensic analysis on your tests after you've run them without having to go into the bowels of a server and find some logs. And then so on, all of that is sort of orchestrated by the manager, and the manager uses two tools to do that. It has the projects database, which is sort of it's just a database that keeps track of all the projects that Summit is running, and then a front-end container, which is what we use to interact with Summit. So we found that, we initially just had all these database tools and some Python plotting utilities, but people wanted to be able to see what was going on with their test really fast, and we found that the best way to do that was just to build hooks into the databases that were visible from a web GUI. So anyone can just pull up a web browser on any computer or tablet or phone and see what's going on with all of their testing. So I mentioned the one edge case for testing flight software where normally you have a test environment for your flight software that just exists within a container, and if your flight software tests run in that container, then it easily folds into Summit. But we have a few projects where we need to launch thousands of containers of flight software that all work together and interact. And obviously you can't sort of have that kind of nested containerization without having massive performance penalties. So we have a specialized runner that can kind of break out of the test environment and launch a large number of other containers, and it sort of links them all together to the same database so that those containers can either all run separate tests or all run together as a large test, and then report the results back to the parent project environment. So I mentioned some of the web-based reporting. Summit deploys sort of this web-based front end that aggregates all the data from the project database and displays it for the developers. So you can see real-time updates from your sims and see how long they're taking, whether or not they're passing and failing. And so we have a few deployments of this that are running 24 hours a day, running tests, and you see all these real-time tests for whatever you're testing, and you can see pass-fail in real time and get reporting immediately, which is nice. And we also save tons and tons of historic data from all of the tests, which is, and we found this to actually be, from a developer's perspective, to be the most useful thing that the tool does, is it kind of lets you see everything that's going on with all of the scenarios that you're running of your flight software. So this vertical axis here is a set of scenarios, although this is a reduced set because there's actually more scenarios than we could fit here, where we're testing all of the flight software doing different things that it needs to do. And historically, you'll have kind of unit tests where you will run a part of your flight software and make sure that your flight software, that component does the thing it's supposed to do. But as some of our missions have become more complicated and more intertwined, we've noticed that changing one component, if it has lots of interactions with other components, tends to have non-deterministic effects and can introduce flaws that you wouldn't necessarily expect, and there can be lots of unintended consequences. And this, because it's running all of the tests all the time, lets you know as soon as you've introduced something that has those unintended consequences on other parts of the flight software. So you can kind of see, here's an example of something where that happened. All these tests were passing. They've been passing for weeks, but then I think we're working here on sort of this complex feature, and one thing that we did here broke a whole bunch of other tests throughout the system. But because we had this utility running, we found out the next day that that happened instead of finding out weeks later when we finally got around to doing a full day in the life test or something like that that's doing all the tests. So we were able to fix that we were able to fix it by the next day, well, most of it by the next day. One of the bugs took 2 days, but it just we knew when a change broke something, so it let us fix what it broke really fast, which is really, really nice from a developer perspective. So sort of how something kind of fits into our workflow currently. We do our flight software development and sort of standard development where we interact with the Git repository, and we have our standard pull requests. And this pull request is where we encompass sort of our standard continuous integration work. So that's unit testing for all of our merge requests to make sure that they pass the standard set of unit tests, and that it's not breaking everything, at least when you try and merge in software. But then that is automatically taken by the simulation control interface that automatically runs all these parallel simulations to verify that every component of the software is doing what it's supposed to do. It runs a bunch of multi-satellite simulations. It has high fidelity models, and it makes sure that it saves all this data into a database and makes sure that we're getting expected results. And if it doesn't, then it alerts developers. And it outputs all of that to both a web front end and other visualization utilities. So I don't know if once you start putting all this information in a database, you can do tons of fun things with it, because there's all these great APIs for grabbing data from databases, thanks to all of our friends in the tech industry. So we have visualizations that can just grab data from any tests that you've run historically, just grab it out of the database and visualize it on any computer you want to, because all the sims are stored with a unique ID, and you don't have to plug anything in. It's really great. And anyway, that feedback goes into developers, which influences their flight software development process. So it's just kind of adding all these new capabilities onto our development pipeline. So, it sounds like there's a lot of complicated things, and there's a lot of complicated things going on in the back end, but we wanted it to be as simple for developers as possible. So you kind of just all you have to do to deploy Summit is build sort of this meta repository with your flight software here, and then all of the scenarios that you want your software to test. And from our perspective, a scenario is just a sort of a bash command that executes whatever tests you need to run for your flight software. But it doesn't need to be something simple. It can either, it can take days, or it can spin up a ton of Docker containers that do all sorts of complicated things. But as long as it outputs, an expected JSON format for the final results, Summit knows how to deal with your scenarios. And these are some fancy things for fancy sim that I'm not really going to talk about because I don't have time. But they're not really relevant for Summit. So you can run, even if you just have a really simple flight software program, you can just populate these top parts, and it'll be running in Summit almost instantaneously as soon as you push it up to the server and add it to the project's database. And I mentioned, feedback for developers, and so this is what some of that looks like. They're configurable analysis pages. So I mentioned, a lot of times after a test fails, a developer will have to go into the logs to figure out what was going on in the test. But what we've discovered is that if there are certain things that you find developers are looking at a lot, so for one of these, multi-spacecraft configurations when in an oil or hill frame, or delta Vs, we found out people really cared about those for a lot of the tests, so we added them to the web front end. And because we have access to all the historical data from all of our sims, it's really easy to grab and just populate and put it on the web front end, so that instead of having to go through some process of grabbing the data from a server and running some scripts to plot it in MATLAB or Python, it just, you load a web page and it's there. And then we also have hooks for all of our sort of developer tools. So we have an internal chat server, and we just, it's really easy because it's all web-based to send data to that chat server, so you can say, hey, this test failed, this test passed, and alert relevant people based on the results. Okay, so this is where I would be doing a demo, but I think we have a video instead. Okay, so this is the Summit landing page. if you play it. Okay, so this is what it looks like when you go into, this is a pretty simple flight software project that we're just beginning. So it just has a few tests that take a while to run, but they're not a lot more complicated than unit tests. And you can see the results, and it saves them, and you can scroll through them, and it's easy to see. But so I think we're going to go look at a different flight software project that has a little more going on. Oh no, I'm going to look at the historical results data. So you can see that table. This one has significantly fewer scenarios than the one I showed in the slides, but you can still see that historical data. So here's another project that has more going on. So this is for DARPA Blackjack. So we have this is one of the instances where we had to run tons and tons of flight software containers. So there's actually several hundred flight software containers running in some of these tests that are all interacting with one another as a part of a, I think this one is a 90-sat constellation. So here it is, here's the web loading all of the spacecraft position data. And then you can show the space vehicle final positions if you want and look at them. And then I think I'm going to go down and look at the ground track. So these are little custom web apps that we wrote and inserted for this project because it was, it's a project-specific thing. But now we have these little web apps that we can add to any project. If you want to get ground track, you can get ground track. Or if you want to get a constellation view, you can get that too. As opposed to like other projects where we had like the delta V and that the RIC frame information. And so here we got the historical test data, and we also have like filters. So if you want to, you can see what happened in a test, but if you want to just look at tests that fail, we got filters to sort of query the database in specific ways to get all that information right away. And if you click on those, you can actually go into log information, but that would be impossible to read, so I didn't go into there. But yeah, so we found it's a very useful tool, and it's not really, some of our recent autonomous multi-spacecraft projects that we've been working on, we could not have accomplished, we couldn't have finished the software development without this massively parallel testing because our test team was just like getting really, really overwhelmed with the amount of tests they ended up having to run. So we figured out we had to do this massively parallel thing, and then we built this tool around it, and we think it's pretty cool. It's been helping us out a lot. So, anybody have any questions?
Questions? Oh, Jason, I think you get a prize for asking the most questions.
I was going to wait for somebody else. Were you all going to make this open source project?
We are not sure if we can because of who paid us to develop parts of it. Yeah.
Just a quick follow-up to that. So you published a white paper or anything with some more details?
This is sort of like it's like a pre-alpha version of something that we just developed internally. And we're not trying to like sell it to anybody or anything right now. We just we thought we think moving to this sort of massively parallel containerized testing is going to make a lot of sense. And I think it's for sort of like the flight software industry. Mm-hmm. So we just kind of wanted to let people know what we were doing.
Yeah, thanks.
Other questions? Okay, great. Thank you.